Have you wondered just how much generated electricity actually makes it to you? You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy. Hi, this is Dennis Stout, and thank you for joining me for this episode of the Windfarm Guy. Today we're going to consider energy itself. More specifically, how much energy actually makes it to your plug, and of the energy that doesn't quite get there, where does it go? Albert Einstein said energy cannot be created or destroyed. It can only be changed from one form to another. You know, most power plants are doing the same thing, be them coal, natural gas, petroleum, or nuclear. They work on the same general principle. Energy-dense stuff is burned to release heat, which boils water into steam, which spins a turbine, which generates electricity. But there's a nasty little secret here. The thermodynamic limits of this process mean only 2/3 of the energy in that raw material actually makes it onto the grid in the form of electricity. In other words, those power plants are losing a lot of power. In 2013, about 65% of the energy stored in the resources was lost in the power plants itself. By the way, that loss is totally bypassed using wind turbines. Now, wind turbines don't convert 100% of the wind, but what energy a turbine doesn't convert still has the potential to be captured and converted by another turbine. Once a fossil fuel is burned, its energy has been released and can't be used. Once the electricity is generated, it is then placed on wires and sent to cities and factories. Along the way, those electrons bump into each other. That crashing together creates heat, and heat is energy. That heat dissipating are actually more losses called line loss. You can literally hear it happening as you hear the buzzing and crackling along the lines. And you can see it happening when you see the line sag due to the heated line. Interesting thing, the lower the voltage, the more losses there will be. So the smaller distribution lines near your homes, they total an additional 4% loss, while the larger high voltage transmission lines only add about 2% line loss. Then once the electricity arrives at the home or office, it's used in all the things that we have there. But guess what? There in your walls and in the appliances, there are more losses. And all of those losses from beginning to end total a lot. If you really think about it, of all the stored energy that was originally in that chunk of coal or that cube, that block of gas, apparently only about 1/4 of it actually gets used at the final destination. But you know what? Wind, solar, and hydro convert what they can and then send it down the line with less than 10% losses. Why the difference? It's because these resources don't have to generate steam to convert the energy. If you like the things I've shared today, be sure and click like and subscribe below. Also, leave a comment below if you'd like to. All electricity is subject to transmission line losses, distribution line losses, and the final conversion loss when we finally use it. However, sources that must convert the energy to heat to make steam also add a significant conversion loss from the outset. This is Dennis Stout, and I'm the Windfarm Guy. Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.